additive manufacturing for polymers, additive manufacturing for metals, additive manufacturing for ceramics, and of course nowadays we are able to produce a very complex shapes with the help of additive manufacturing. So as an institute, we are happy to host you to see the additive manufacturing center, where you can have aluminum. We are using aluminum as raw material. So metal additive we can have the ceramics also. So those are interested, of course they can visit our institute. Then after that we have autonomous robots, and then we have big data along with the cyber security. So cyber security is a thing where, of course, whenever we have the system integration, and when we are connected to more than 50 departments, of course it is the need of R. And then out of this, now today, for today's session, I would be spending more time on the autonomous robots. And after that, the overall classification that Akshay Sir will tell you. So this is, you can see the industry 4.0, where you have smart automation, you have robotic motions, you have PLCs, of course these are the part of automation, intelligent nodes, different types of robots and cobots, and smart mesh for industrials. So when we have these different set of departments, but which are connected through IoT, that we call as right now the real-time data generation. You can see on your laptop, on your tab, you can see what type of work is going on in particular X department, what type of work is going on Y department. So all that integration we can say. So that is our industry 4.0. And now in this, we are also going ahead by using the robots and cobots. So again, one more example that gives a clear idea about the industry 4.0, where you can see we have very minimum intervention of human being in the system. You can automatically see the process is going on, robots are doing their work, the system it is counted, the assembly line where you are getting your assemblies done, and then you have cards which is kept on a store, and we have the integrated system. There you can, each and every packet is accountable. So that is your industry 4.2. And now we are now emerging towards industry 5.2, which talk about the sustainability, resilient, and of course these are the human-centric. Now sustainability is SDGs, everyone is aware about sustainability goals. So in line to this, now industries start making the changes, right? We are now going towards the green manufacturing. We are going towards the green technologies, and of course by considering the human centric. Now the question arises, when we are talking about the robots, what about the human being? Is it impactful, or how much it is impactful? Similar thing you can compare with the AI. Now AI is an integral part of everyone right now. We are sending emails, right? We are preparing some paragraphs, we are sending some messages, we are scheduling something, we are taking help of AI that reduces your time. But of course, the prompt that has to be given, for that you require human brain, right? Similarly, you can't prescribe medicines from AI. These are the limitations. So, where we need to stop, and where our exact position of industries. So, this shows, like here Robo is saying we don't have worker on the shop floor now. So, is it a case? Kutle worker eliminate hotil? Those are not able to use the emerging systems, emerging technologies. So you can't resist the technology. You can't, because this is the industrial revolution. Right now or next year after that, of course, it has to become. There has to be cost, because when we are industry, people are running industries. So of course they have their own mindset, they have their own calculations, they have their own productivities, and by considering that, of course, the part of robotics is important. And now we require the people, we require the worker, we require the man-force who is aware about the automation and robotics. So this is the requirement where we are not replacing as such worker, but we require a worker who is aware of the robotic system, who is actually the worker who can shake hands with the robot, and it will enhance the productivity of industry. So these are the few photographs that you can see where purposefully we have kept SDGs, gender equality, where a female worker who is handling the robot or cobot and effectively, very effectively, because these are the cobots which having no harm while they are handling this. So these are the intelligent robotic system we have. After this graph shows that on x-axis we have productivity, on y-axis we have flexibility. Okay, when we are moving forward for the better productivity, of course, there is a call for the automation, and of course there is the elimination of manual labor. But it does not mean that we are not using them as a resource, but effectively we are making them aware how to handle the robots, how to handle the cobots, and then we are use them by increasing their wages. So now we'll have some discussion on collaborative robots. Now robots are the integrated systems which involves some mechanical parts, which involves some electrical parts, some electronics parts, and the languages, programming languages, which can integrate and make a system which is more flexible, right? And which is not being, we can use it for 24/7 as per our requirement. And now, currently we are using the collaborative robots that we call as cobots. Robots are independent systems to which we are providing some input, then they will operate. It's like the human being, they are having the controller, like the brain we have, they are having the arms, the way we have, enablers they are having, so that they are designed to perform certain operations within the constraints. But when we are talking about the next technology in that, then we can have the cobots the word comes from the collaborative robots. And for the first time, we got its evidences in between 1960 to 2000, where the robotics revolution starts. Now, if you see the use of cobots, that is extensively we are using. You might have heard about the KUKA Fanu. These are the one of the best manufacturers globally. But when you are talk about the cobots, you can refer for ABB. Excellent cobots they have. We can have KUKA and Fanu. And the cell phone assembly that right now which is going on in new plants of Apple, that plant is in, there are two plants, one is in Chennai, another is in Hosur. And if you can refer, all iPhone are assembled with the help of cobots having a payload less than 6 kgs, less than 8 kgs. And they are very fast, very active, and they are very safe, because when we have the interaction between the cobots, there is interaction between two robots as well as there is interaction between the worker who is engaging in that particular task. So, if you see, there is a huge demand for the development of cobots which is coming nowadays. So, collaborative robot market, if you see, it is increasingly, extensively, because of course now we are using the cobots here, or before that when we are using robots, how to operate this we have to program, right? Either we have to program or we have to teach parent to give instructions. But there are now cobots where you have to give the path. If you give them a path, this is the way how you have to operate, this is the way you have to operate, they will regenerate by themselves and do the repetitive work until you give the command of stop. So that would be the level right now. Similarly, we have the cobots which are based on the AI technologies as well. Now, just imagine, if you give this water bottle to one of the robots in front of you, okay, and the task is they have to pick it and place to some other place, right? Now, as a human being, we have sense. Yeah, this water bottle, we know how much pressure we have to put to pick and place. Suppose there is a piece of paper. We know how to pick it and place. But how do you give instructions to the robot? If you program that to handle some metal parts, so they have their intensity to pick and place, because they are having pressure, because they are handling the metal parts. But if you change the raw material, if you give some glass there, if you give some toothpaste, if you give some your cell phone, robots have no idea. They have no idea how to deal with this. They will do the pattern whatever they have learned. ज्या प्रेशर ने त्यांनी मेटल पिक करतात त्या प्रेशर ने मेटल पिक आणि प्लेस करतात. मग हे जर तुम्ही पेपर दिला तर what will happen? There would be chaos on the shop floor. ह्याच्याऐवजी तुम्ही दुसरं काहीतरी द्या, इलेक्ट्रॉनिक्स काहीतरी द्या. How you will realize your robotic systems or robotic system, how to sense this? How to do that? क्वेश्चन कळा था स्टुडंट्स को? करेक्ट. समजा तुमच्याकडे टूथपेस्ट तुम्ही दिली आहे, रोबोटिक आर्म टूथपेस्ट से काय करेल, जे रोज मेटल हँडल करायला लागेल. So what they are doing right now? They are using, of course, there is one solution that we called as image sensing. Image sensing, what they will do? They will capture the image. You will understand whether this is vertical, this is horizontal. They will understand how robot or cobot will get idea about how much pressure I have to that is the tactile sensors we are using. जेव्हा आपण एखादा फोर्स देणार आहे त्याला, त्याच्यासाठी आपण टॅक्टाइल सेन्सर यूज करतो. टॅक्टाइल सेन्सर्सला तुम्ही इनपुट कसे देणार की हे रॉ मटेरियल कुठलं आहे. अँड ऑफ कोर्स you cannot use all similar materials throughout the year for next 10 years. Of course, there is a change in the system. So your system has to be resilient enough, decision making enough. As there is a change on a shop floor, the robot or cobot has to change their decisions. So how to do that? So for that purpose, right now we have the sensors, vision sensors. ते काय करतात, आपण त्याला मशीन लर्निंगनी ट्रेन करतो की जर बॉक्स असेल तर तो बॉक्स कुठल्या टाइपचा आहे आणि त्याच्यामध्ये मॅक्सिमम पॉसिबिलिटी काय आहे. दॅट माइट बी अ लिक्विड, दॅट माइट बी अ सॉलिड, दॅट माइट बी अ गॅस. it is hollow part, is it circular, rectangular, आणि त्या मशीन लर्निंग जेव्हा आपण ट्रेन करू मग तुम्ही टॅक्टाईल सेन्सरला एक इनपुट द्याल की दिस इज पीस ऑफ पेपर, देन यू हॅव टू पिक व्हेरी सिम्पली, नो नीड ऑफ एक्सेस प्रेशर यू हॅव टू गिव्ह. Of course there are some metal blocks, then tactile sensor will give, of course this is the thing. So here the call came for the use of AI in your robotics or robotic systems जे आता actually आपण industry मध्ये use करतो. So as a core department we are representing core department, so you cannot go away from the AI, but of course we need to include this. See, as a vision sensor again it is a part of your sensors and controls, correct? But we have to integrate AI to make our robot understand what I am doing with this. ह्याला पिक करताना मला प्रेशर किती घ्यायचं, so for that purpose I have to train my system, and of course there is no requirement of a big hardware or software, but there is a requirement of AI and of course some machine learning part to make habitual our robot, because you can give a data like there are 500 things you need to pick, 500 things to pick करायचे, त्याचे ह्या कॅपॅसिटीज असतील, त्याचे लेंथ आहे, विड्थ आहे, हे त्याचं स्ट्रक्चर आहे, फॉलो आहे, whatever the instructions you can give, you can train your robot and now give. And I have seen, I have witnessed in many industries, you change the raw material, the pressure will change, you change the shape, the of course how to handle that system. So all those parts that coming, and of course we need to work on this, and this that's why we are introducing, we are here at 2025, but the market is going to increase for specifically cobots and robotic systems, because everywhere we are trying to introduce that, and we have to be a part of this by learning new technologies related to the robots and cobots. So here you can see collaborative robots and Industry 4.0 and their subsystems that we have discussed in previous slides. And now I would like to talk about the digital twin technology. Have you heard about this digital twin? Right now in many industries they are extensively using digital twin, but as a institute it is very difficult to bring those, because these are new emerging technologies. Okay, so after this we can start something, working on it as a project or capstone project or mini project, and of course we can help you to understand this. So basically digital twin is a virtual replica, and it is different from the simulation. Currently in our curriculum we are working with the simulation part, correct? But simulation and digital twin, these are completely different. That I will differentiate the things when we are going ahead. First of all, we can understand why it is important. It is important because it predicts the failure before they occur. After that, it optimizes the design and performance, and it enables the real-time monitoring and simulation data. Now here the simulation, whatever we are having is different, but here it gives the information about real-time monitoring and simulation. So this originates from one of the space mission of NASA in Apollo 13, where there is tragedy happened with the oxygen tanks when it is in a space, and now scientists, they don't have any data how to manage this and how to bring our people back to the Earth. But thankfully NASA had their one of the replica on the Earth, and they get the conditions from the environment. They start working here by making this as a digital twin, And once they understood what is the expected in this particular environment, then they try to repair it, the oxygen tanks in the spacecraft, and then they bring it back to the Earth. So this originated in Apollo 13, where we got, see, this is the physical system we have, and this is the replica. But again, the similarity is, this is the physical system and this is your sensor based system. So whatever pressure we have, you can monitor. Correct? Whatever temperature you have, you can monitor. And not only monitor, you can of course vary it. So simple example is our smartwatch. In the night when you are on the bed, you can see what you have done today. You got up at 5 o'clock. What is your time? Gym time, sports time, your office work, number of steps, peaceful, how much peaceful you slept yesterday, heartbeat, everything. So this gives the data which converts a human being to one of the digital, and that resembles as a real system. So basically, in digital twin, we have 3 steps: see, think, and do. So for the better understanding, we have taken one of the physical system here. We have connected various sensors, and similar replica we have seen here. This is the digital one. And now whatever the changes that you can make on physical system, similar you can see on your digital twin. And now this is a see mode where you can see or you can monitor the change in the parameter. After that, when we apply this, we got some data. That is the feedback, historical data, new input. That means what? We have the system which is in the operation, and that comes with that comes with your AI, machine learning, simulation, and data science. So that is the integration of all your hardware related. Of course, we are attaching number of sensors. From the sensors, we are extracting the data, and based on that, you can have a think call. So what would be the limitation? What would be the constraints? What decisions I have to make? And then we have to set some boundaries when we have to act, and that we call as a do. That means, again, without disturbing a physical system, without touching a physical system, but by controlling the digital twin, you can actually control your physical system. That means this is extremely useful for the terms of the maintenance. There are, of course, the industry people we have, they know better than us how critical is the maintenance. But when we are talking about the digital twin, of course, through the digital twin, that will be very much easier to understand about the maintenance and to keep our system run. So this gives some differentiation between digital twin and simulation. Now, simulation is based on the assumption, but while digital twin is based on realistic data. On this particular time, what is the actual situation? Based on that, we are getting the results, and based on that, we have to take the appropriate action. Now, this all you can understand with the examples. Tesla car. Each car has digital twin updated with live drive data, which improves the safety and performance. So when you are driving, you can see one of the digital twin of the car on the screen, and that of course increase the safety and of course the performance. While the simulation, we can have the various simulation like your crash test, which predicts the data, but of course the digital twin gives the exact realistic data of that particular time frame. And of course that would be very much easy to take decision. And decision for your predictive analytics, optimization and real-time decision making. Now, this part gives digital model, digital shadow and digital twin. Now see, this is the thing where you can have the progress in the digital twin model. That means I will. So that we can cover while we will have one video which gives some idea about it, and then we can go for activity.
Operator, a change in my mission is causing damage to my HP turbine rotor.
Okay, Twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39, the number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over the last 6 months. If this continues, I would lose 69.9% of my useful life.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing and my present condition, I have 2 options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor. Option 2 is to download the Oplex app that applies stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is flex start. Thank you.
Okay, good morning.
So the case study of General Motors. The data that we have seen, the video that we have seen, which gives the idea about what industry is doing right now. Because if we ask to get similar data, it will take near about a month or 2. The prediction, again new work, again rework. But with the help of this particular system, it would be extremely easy for the industry to work on the problem statements, to work on the maintenance, to optimize the system for the better results. And that gives, and of course this is not only like your visuals we are getting. It's not like we are only having some visuals. It is based on the realistic data we have. That means we integrate whatever the hardware we have along with the sensors. We are getting all the data of every single minute. We are generating, we are getting in the cloud. It is not only a software based, but it is in a cloud because we are integrating overall system. And then we are trying to optimize at all phases so that we are getting the better results. So whatever the data we require, we are here to provide you with the help of this. So that gives the idea of your digital twin what our industry is using. Now these are the applications right now we have for the process simulation optimization. For casting simulation, of course, it is extremely useful. Currently, we are using some softwares to to identify the solidification, their cooling rates, right? But we are going ahead with this by using the digital twin of your castings. After that, the real-time monitoring with the IoT sensors. That means you can use different hardwares, we can use different sensors there to monitor different parameters, temperature, pressure, gas level, vibration in real time, and that would be gives better idea about it. And after that, worker safety, of course, which is extremely required when we are talking about the castings. So when we by bringing this to the shop floor specifically for as this FDP is concerned to casting industry, we try to showcase utilization of digital twin for foundries, where you can use some AR/VR practices to the workers for their safety guidelines, and of course with the help of digital twin, they will also understand what is going on. Even the hierarchy what you are having in the industry, they will understand on every stage what is going on, and of course it is helpful for the management team to get the decision or to have a decision based on the predictions. So this it shows the digital model first what we have, then we have digital shadow, but right now we are having the digital twin. That means we are having specifically real-time seconds to seconds data of all hardware systems on your tab. So after this, we will have one small activity among us. You can make a group of like 3-4 students together. We just required a paper and one page where you can, if you want to set up a smart manufacturing cell for any automotive component, yourself you have to decide. Me robot kudna choose karen. Shall I go with the robots? What type of IoT system I will use? Where I will go with the digital twin technology, and you have to prepare on your paper so that we can go for its assessment. For assessment, we will have small criteria. Whatever you have drawn, whether it is visible, do you have any clarity? Use of robots and cobots. Have you kept there with the specifically arrangements there? For digital twin, what you have introduced, is there any feedback, real-time monitoring, what you are doing? And of course, how creative your design is, and of course, whether it is feasible. So based on this, we can, it just take like 10 minutes to finish this, okay? So you can make a group of 3-4 students. काय करायचं आहे आपल्याला एक ऑटोमोटिव्ह कंपोनेंट साठी स्मार्ट मॅन्युफॅक्चरिंग सेल प्रिपेअर करायचं. कंपोनेंट तुम्ही चूज करा. फक्त चूज करताना जी आपण मॅन्युफॅक्चरिंग सेल यूज करणार आहे त्याच्यामध्ये आपल्याला IR4 च्या टेक्नॉलॉजीज घ्यायच्या आहेत. तुम्हाला रोबोट प्लेस करायचं आहे. हे सगळं ब्लॉक डायग्राम काढायचे आपल्याला की इथं रोबोट आहे, इथं रोबोट आहे, IoT सेन्सर्स कुठे आहे आणि डिजिटल ट्विन माझं कुठं असेल. Digital twin you can use it for a single component, single machine. Digital twin you can use it for a cell manufacturing or digital twin which is replica of your industry. So these are basically three types of implementation of digital twin. So that is up to you. So it will give more clarity about what we are trying to learn today. Okay, it will take just 10 minutes. Block diagram फक्त काढा आणि मग आपण असेसमेंट करू. I hope everyone is having paper. If you want to take help from as this generation, you can't imagine the things in better way. You can use cell phones for better clarity of while you are designing your